All right, and in part C, so we still have the same series for um, 1 over square root of 1 plus x. And the question is, so if we want to use it to estimate 1 over square root of 0.8 with an error of 0.02, so just how many terms are going to be enough? Now, I'm going to again use the same formula from the previous um, question. Right? So the general formula is that the error um, of estimating the sum of the Taylor series, or the error, sorry, the error of estimating the function with the sum of its um, first n terms of its Taylor series is this, right? So it's f n plus 1 of c. So this is the derivative of order n plus 1 divided by n plus 1 factorial times x minus a raised to the power n plus 1. Now, in our case, so this is the general formula. So in our case, when we key in our own function and our own n plus first derivative, we will get this 1 times 3 times and so on times 2n plus 1 divided by 2n plus 1 times n plus 1 factorial times 1 plus c to the power minus 2n plus 3 divided by 2 and um, well, okay, x raised to the power n plus 1, right? Okay, now well, in our case, so we are looking for 1 over square root of 0.8, so which is 1 over square root of 1 minus 0.2. So our x is, well, it's really absolute value of x is 0.2, well, minus 0.2. So our absolute value of x is essentially 0.2, so it should be 0.2 to the n. Okay, so the tricky part here is c, right? So that's why we don't know what the error is actually, so we can only estimate it. Now, c is between negative 0.2 and 0, since our x is 0.2, and c should be between that and 0. And the question is, so for which value of c is this term the largest? And as I already said in part B, this expression 1 plus c raised to a negative power as a function of c, it is a decreasing function. So it is the largest when c is the smallest. So which means that when c is negative 0.2. So the error is actually less than 1 times 3 times and so on times 2 and plus 1. The product of odd numbers from 1 to 2n plus 1 divided by 2n plus 1 times n plus 1 factorial times 1 minus 0.2 is 0.8 raised to the power minus 2n plus 3 over 2 times 0.2 raised to the power n plus 1, and this should be less than 0.002. Well, basically, we've got to just to try these, and see for which n this inequality is going to be actually true. Maybe let me show you how to do this in Desmos Calculator. So there is a little trick that I think will help, right? So the little trick that I have is the following. So 1 times 3 times 5 times and so on up to 2n plus 1, right? So this is the product of odd numbers. But we really, you can't really enter it into Desmos Calculator. You can enter a factorial, right? And in order to get a factorial, you basically need to multiply by all the even numbers in between them. So it's 1 times 2 times 3 times 4 and so on up to 2n plus 1, right? But then in order to really get it right, I need to divide by all the even numbers up to 2n. Now the numerator is going to be 2n plus 1 factorial, and the denominator is a bit, so now all these numbers are actually even numbers, so which means that you can take out all the 2's from them, and by doing this you will get n copies of number 2, and then you're going to get a product of numbers from 1 to n, 1 to 3, so which is just n factorial, right? So my point being is that we can replace the product of odd numbers in the numerator here with 2n plus 1 factorial divided by 2 to the n times n factorial. So this is just needed so that it's easier to enter into Desmos Calculator. That's all, right? So this thing is really 2n plus 1 factorial divided by, okay, so we have 2 to the n and 2 to the n plus 1, so it's going to be 2 to the 2n plus 1 times what? I have n factorial, and another n plus 1 factorial times 0.8 to the minus 2n plus 3 over 2 times 0.2 to the n plus 1, right? So this is my error. And now I guess I can, start the Desmos calculator. Okay, let me, do it so that I still can see my equation. All right, so let's say n is 3, whatever. Now, so the error is going to be the following. So 2n plus 1 factorial, 2n plus 1 factorial divided by 2 raised to the power 2n plus 1. Okay, 2n plus ups 1 plus 2n is easier to enter, n factorial times n plus 1 factorial times 0.8 raised to the power minus 2n plus okay, where is this? Yeah, and times 0.2 raised to the power n plus 1. Okay, so this is basically the error when we estimate a given number with 3 terms, and I think it's already smaller than, so what was the question again? 0.02, and I think it's already smaller. Yeah, but if you really want more terms, and here's the error with 4 terms, 5 terms, 6 terms, and so on. But again, so essentially this is the error itself, and then if you really wonder if this is less than 0.02, then you can subtract it, and you can change the slider here and look when this number becomes negative. So when n is 2, this number is still positive, but when it's 3, this number is negative. So which means that the 3 terms are sufficient.